Hello, hello everyone. So today we are going to discuss about gas liquid chromatography. So there are two lectures on chromatography. So this is I think third lecture, that is gas liquid chromatography. Okay, so let's begin. Let's start with a slideshow, huh? Yep. So there are some important terms related to GLC. Okay, let's see. GLC stand for gas liquid chromatography. What? GLC stand for gas liquid chromatography. GLC is basically a column chromatography. So you can say that GLC is the successor of column chromatography. Okay, and gas liquid chromatography, that is GLC, or we can say that is gas chromatography broadly, that is GC, was developed by Archer J.P. Martin and A.T. James in the early 1950s. Okay, so you have to remember those scientists name: Archer J.P. Martin and the another, that is A.T. James, in the early 1950s. Okay, so next, so going to next slide. uh, okay, एक second. So, yeah. The next slide is about stationary phases of GLC. We know that there are two phases in chromatography. One is your mobile phase. One is your mobile phase, and the second one is stationary phase. Okay. So first we have to study about stationary phase. Then we will move to the mobile phase. Okay. So the stationary phase in GLC is a liquid phase which is dispersed over a solid support. So stationary phase, that is a liquid phase that is dispersed over a solid support. And the second one, the liquid that is used should be non-volatile in nature. What? The liquid that we used in GLC should be non-volatile in nature, and it should be thermally stable, inert. And here, give me 1 second. uh, yep. Yep. So here inert means what? Or sorry, inert. No, no, no. Inert. Inert is that is not reacting to anything. That is inert nature. But what do you mean by non-volatile nature? Here, non-volatile substances do not readily transfer into the gaseous phase. Simple meaning. The second one, have a low vapor pressure. Third, have a high boiling point. And fourth, have 1 second. And fourth, have a strong intermolecular attraction. Okay, and here the inert means what? A substance that is chemically unreactive, meaning it does not readily form a new chemical bonds or undergo chemical reactions under normal conditions. That is inert nature, means it is chemical, it should be chemically unreactive, does not readily form new chemical bonds under normal conditions. Okay, the separation occurs in the liquid phase when the sample dissolves in the liquid stationary phase. It means separation of liquid phase occurs when the sample is fully dissolved in liquid stationary phase. Commonly used liquid phases are your petroleum, sorry, I am extremely sorry. This is polyethylene glycol, silicon oil, silver nitrate in propionyl glycol. So here, that is the example that I shown here, polyethylene glycol 3350, and the second, that is silicon oil, right? And here I shows that inert solid support, and this is your column, stationary phase and mobile phase. Okay, so the circles that are showing here, that is stationary phase, and the remaining portions are mobile phase. I mean, in this portion is, you can say, this is mobile phase. Okay, let's move further. Sorry. Okay, so this is mobile phase of GLC. Mobile phase is a non-volatile inert gas. Okay, mobile phase is the non-volatile inert gas. It is also known as the carrier gas. That means it carried the components which you are going to separate out, and this carrier gas must be pure. This carrier gas must be pure, and questions that strike here, that why we used pure carrier gas, because the carrier gas must be pure because it helps to prevent reactions with the sample or stationary phase, avoid baseline noise, protect the detector and column, and ensure accurate and reliable separation with detection of the sample component. So carrier gas must be pure and is one of the most important properties of GLC, gas liquid chromatography's most important property is it should be pure. The carrier gas must be pure. Most commonly used gases are argon, helium, nitrogen, hydrogen, and carbon dioxide, depending on the sample used. What kind of samples you are using? In that way, you can choose these types of among these gases. Either you choose argon or helium, nitrogen, hydrogen, and carbon dioxide, etc. Okay, let's move further. And this is the principle of separation in gas liquid chromatography. Earlier I said that GLC is the successor of column chromatography. So here also same principle applied, that is partition principle. So GLC is based on the principle of partition. The components of the vaporized samples are fractionated due to partition between gaseous mobile phase and a liquid stationary phase. Okay, so those components were which are going to separate, the first of all they are fractionated due to the partition between gaseous mobile phase and the liquid stationary phase. Okay, when a sample is introduced through a gas, when a sample is introduced through a gas into the column, the sample components distribute themselves between the liquid and the gas phase. Let's suppose it is an sample, right? Sample that is introduced through a gas into the column. Let's suppose it is the column and it is introduced through the gas, right? Then it is distribute themselves between the liquid and the gas phase. Suppose here it is liquid and it is gas. The component it is depend on that component, that which substances is suitable for that. Either it choose the liquid phase, or it can choose the gaseous phase. Okay, so the next, the component which is distributed more in liquid is retarded more, and the component preferring the gas phase is retarded less. Obviously, it is obviously because uh, the component is easy will be easily separate out with the help of gaseous phase, not liquid phase. So if the component is carried through the liquid phase, it then it will retarded. If it carry with the help of gaseous phase, it will retard in less time. I mean it executed out in fast, right? The components of GS. Let's move the next slide, that is component of GLC. Okay, uh, let's see. There are seven components are there: tank for carrier gas, flow regulator, injection port, column, temperature controlling device, detector, and microprocessor recorder. Okay, the seven components are required in GLC to make the process happen. Okay, so this is your gas tank, and in that gas tank there are carrier gases also, and this is regulator. I I mean you can say flow controller, and this is injector point or injector port, and this is column, it is column oven and detector. Okay, and in the system there is also a temperature controlling device. It is not shown here, but there is a obvious temperature controlling device always. And this is the detector, and also a microprocessor recorder also there. You can say it is a chromatogram. Okay, it is a chromatogram, right? So these seven components are required in GSC. Okay, let's move the further. And this is types of column. Which types of column, I mean what are the types of columns we can use in GLC? So column is the most important component of GLC. We also know that there can be analytical column and preparative columns. Okay, they can be analytical and preparative. The columns can be either packed columns or open capillary columns. Okay, packed column or open capillary columns we can use. Okay, let's move. The first, that is packed column. They are made up of steel, copper, or glass tubing with a diameter of 1.5 to 9.5 millimeter. They have a length of about 1 to 15 meters. The packed columns filled with inert support coated with liquid phase, and it is used for preparative purpose. Okay, let's see what it says. Okay. Um, Okay, it says that what do you mean by packed column? Packed column means there will be no space inside the column for the flow of liquid phases or gas phase. Okay, so they are made up of steel. Okay, so this is your an example of packed column. So these are made up of either steel or copper, or we can say glass tubing. Okay, and their diameter is only 1.5 to 9.5 millimeter only. Okay, and they have a length of 1 to 15 meters. You can see the length of the column, right? So this is so it is very long. So listen, the more less the diameter of the column, the more will be the length of the meter to flow the liquid or gaseous phase rapidly. Okay, next, the packed column is filled with inert support coated with liquid phase. Inside the column, it is packed with what inert support coated with liquid phase. Okay, so it is packed with liquid phases. It is used for preparatory purposes. Also remember that it is used for preparatory purposes. Okay, let's move the second type of column, that is open cap. X second, one second. The next, that is open capillary columns of their types. They have open unrestricted path for the mobile phase with the columns, and the open columns are of three major types: WCOT, FCOT, FSOT. Okay, so this is the a slide example of open capillary columns, how it works, sorry, how it shapes. So this is outer lining, that is a polyamide coating. The next next, that is next to the polyamide coating, that is fused silica. Next, stationary phase, right? And this is your inner sorry outer diameter, and this portion is inner diameter, and this portion, that is film thickness. Okay, let's move further. Right here, WCOT, wall coated open tubular column. There are types. Open capillary columns types. The first one is WCOT, wall coated open tubular columns. A liquid phase is coated with a very thin layer to the liquid stationary phase on its internal wall. What it says, that a liquid phase is coated with a very thin layer to the liquid stationary phase. With a liquid stationary phase, a liquid phase is coated. Here a fixed liquid phase, right? So then we move to the next slide. That is Scott. You can say Scott or SCOT, support coated open tubular column. Right. Here the wall is lined with a solid porous support. Where is the solid porous support? So the and it gives increased surface area of the stationary phase. It also gives the increased surface area of the stationary phase. The inner solid support of the column is mainly derived from diatomaceous earth obtained from the cell wall of diatoms, which is obtained from cell wall of diatoms, that is diatomous atomaceous earth, right? That is called support coated open tubular columns, that is support coated open tubular columns. Next, the next one is FSOT, fused silica open tubular columns. Here the wall of the capillary fused silica tube is strengthened by a polymer coating. These are flexible and can form several coats. It can also form several types of coats, right? In GLC, the sample is introduced in the vapor form. In GLC, the sample is introduced in the vapor form. The liquid samples are dissolved in suitable organic solvent like ether. They are injected, for example, in heftane and methanol by a syringe into a small heated chamber to vaporize them. The detector used in GLC can be of different types like thermal conductivity detector and frame ionization detector. So what it says in FSOT, let's see. Yep. So in FSOT, it says that the wall of the capillary tube is fused with a silica layer, to strengthen the capillary tube. Second, these are flexible, can form several coats. And third, liquid samples are dissolved in suitable organic solvents like ether. And fourth, they are injected by a syringe into small heated chamber to vaporize them, and the detector used in GLC can be of different types like this. Okay, let's move. The next slide shows application of GLC. What are the applications that are used in GLC? It helps in separation of components like tobacco smoke, atmospheric pollutants, solvent, plant extract, essential oils, and organic acids. Remember that atmospheric pollutant, tobacco smoke, solvent, plant extract, essential oils, organic acids. It is used for qualitative and quantitative analysis. It can be also used qualitative and quantitative identification of contaminants like pesticides, detergents, and pollutants. It is also used to analyze molecular properties such as vapor pressure, molecular weight, and heat of vaporization. Right? Let's move. And the next and last slide of gas liquid chromatography, that is advantages of GLCM. It can be used for both qualitative and quantitative analysis. It is highly sensitive, very small sample size can be used, and analyze can be highly accurate and precise. The analysis is highly accurate and precise. Okay, so thank you very much.